This is example 2 on page 5 of slides 5-3. This is more of an application question of constraint optimization. So here, a shop estimated the following market response function of sales as a function of number of advertisements in magazines X and the number of advertisements in TV broadcast Y. And here, S, X, Y equals to 420x minus 2x squared minus 3xy minus 5y squared plus 640y plus 1725 is the sales. And as a shop, you're using broadcast, you're using advertisement in broadcast, TV broadcast and magazine to what? To promote, meaning you want to maximize your sales by choosing X and Y. Okay, so then let's look at the conditions. Now we're asked to find the optimal advertising plan, which is how many to invest in X and Y in TV broadcast and magazine, right? Given a budget, advertising budget, so you do have a constraint, you have limited money to be allocated among these two. Advertising budget, okay, between X and Y, between magazine and TV broadcast. And also we know the price. The price of magazine advertisement on magazine is $1 per unit, and the price on TV broadcast is $4. Okay, so here then we can write the constraint, which is B greater equal to PX by X plus PY by Y. Why is that? Because here PX is unitary price for advertisement on magazine, and PY is unitary price for advertisement on TV broadcast. So we then the total cost, total expenditure, right, on TV broadcast is PY by Y, on magazine is PX by X. And here we want to maximize our sales. Supposedly, we need to use up all your budget. We shouldn't leave any money on the table, right? So the constraint more accurately should be written as 180 just equal to, we're using the entire budget, just equal to 1 by X plus 4 by Y. So here we have this constraint, and we are going to write this into constraint equal to 0 form for later construction of the Lagrangian equation, which is 180 minus X minus 4Y. So this is the constraint that your maximization problem is subject to, and here we give it a name, the budget constraint. Okay, so after figuring out this, so this is what I always suggest you to do as you're reading the verbal problem. I strongly recommend that you grab a piece of paper, try to translate those verbal language into more succinct math symbols. Okay, then to convert this application question into a math problem to solve. Okay, you always try to make strange things more familiar to you, then you have a more solid basis to solve. So then what we need to do is construct a Lagrangian equation, which is L equals to S as a function of X and Y plus lambda by constraint equal to 0. So here, for demonstration purposes, for maximization of clarity purposes, I'm writing down every step. You don't have to, but here, I just want to make things clear to everybody. Okay, so S as a function of X and Y, we can then copy down this function. So it's 420x minus 2x squared minus 3xy minus 5y squared plus 640y plus 1725, and then plus lambda multiplied by constraint equal to 0, which is 180 minus x minus 4y. Okay. Then, as you're doing this, you should bear in mind x and y, which are your choice variable, they remain as variables, and also you introduce a new one, the lambda, right, to ensure that this constraint is binding. Then let's do the derivative, okay, which is the first order conditions. Partial derivative of L with respect to x equal to 0, partial derivative of L with respect to y equal to 0, partial derivative of L with respect to lambda equal to 0. And I always start with the third one because that's the simplest. All right, so now you're treating lambda as the function. All right, so that is actually, you can rewrite the multiplication here by changing the sequence. It's 100 minus x minus 4y multiplied by lambda, right? So the entire 100 minus x minus 4y is a constant multiplied to lambda. As you're taking derivative, the entire sxy function has nothing to do with lambda, then we can ignore them. We can disregard. And we are only looking at how to derive the derivative of the last lambda included multiplication term product, right? To figure out the derivative with respect to lambda, which is 100 minus x minus 4y, and that equal to 0, which means the constraint is binding. So that's good. Okay, that is your equation 3. And then let's start with x. Okay, so here, to facilitate your calculation of x, we further expand this lambda multiplication into 180 lambda minus lambda x minus 4 lambda y. Okay, so later on, it's easier for us to calculate. Okay, so the first order derivative with respect to x, so now you only treat x as the variable. Okay, starting from first term, the derivative is 420 minus 2 by 2x minus 3 times of y, and then has nothing to do with x, has nothing to do with x, has nothing to do with x. The later 3 terms of xy is disregarded when you're taking derivative with respect to x. Then for the lambda multiplication term, the one that actually enter into the derivative is minus lambda. So previously you were deriving the first order derivative, then don't forget the condition, which is the derivative should equal to 0. So then we can rearrange this. We have 420 minus 4x minus 3y equal to lambda. That's your equation 1. Now we're doing equation 2, which comes from the first order condition with respect to y. So now we're taking derivative of the Lagrangian with respect to y for the entire thing. Okay, so the first 2 terms has nothing to do with y, right? The third term, when taking derivative with respect to y, the derivative is just minus 3x. Okay, and minus 5 by 2y plus 640. Then disregard the last term as a constant, and then enter into the multiplication. The last term in the multiplication has something to do with y, right? And its derivative with respect to y is minus 4 lambda. That equal to 0. Don't forget the equal to 0. condition. So we rearrange this. We have minus 3y minus 3x minus 10y plus 640 equals to 4 times of lambda. So that is your equation 2. Okay, then we have 3 equations to solve for 3 unknowns. We can solve them. So 1 and 2 to eliminate x. So now we have minus 3x minus 10y plus 640 equals to 4 times of lambda. And according to the first term, for lambda equals to 420 minus 4x minus 3y. Okay, then we can expand this. We have minus 3x minus 10y plus 640, which is copied down, equals to 1680 minus 16x minus 12y. And we move x to the same side, x and y to the left-hand side, the numbers to the right-hand side. So we have minus 3x minus 10y, and now minus 16x move to the left-hand side, change into positive, and minus 12y move to the left-hand side, change into positive, equals to 1680 minus 640, which is 1040. Okay, and the left-hand side is 13x plus 2y equals to 1040. So we have equation 4 now. And equation 3 can be rewritten into x equals to 180 minus 4y. We just move x to the other side, right? So now we can take this x in to eliminate x, right? So 3 is taking into 4. So we have 13 by 180 minus 4y plus 2y equals to 1040. Okay, that is 13 by 180 minus 13 by 4, which is 52, plus 2y equals to 1040. Okay, and 13 by 180 is 2340, and here minus 50y equals to 1040. And here first we can divide 10 to both sides to simplify this, and we can move negative 5y to the other side. We have positive 5y. We have 234 minus 104. 104 move to the left hand side, right? So that is 130. That's your left hand side. 234 minus 104 is 130. So your y star equal to 130 over 5, which is 26. Okay. And therefore, x star equal to 180 minus 4 times of 26, 4 times of y, according to 3, which is 180 minus 26 by 4 is 104. The result is 76. So we have the x, maximal x and y, which is 76 and 26. So we answer the first part of this problem. Now you were asked to find the optimal advertising plan. And the advertising plan that we are suggesting the firm is to buy 74 magazine advertisement and 26 TV broadcasts. And then use the Lagrange multiplier to estimate the effect on sales of $1 increase in the budget. So that is basically asks us to calculate lambda star, which is come from the first one, right? Lambda equals to 420 minus 4x, which is 76, minus 3y, which is 26. That should equal to 38. Then here it means elevating budget by 1 unit of value, $1, supposedly. Your SXY will be estimated to increase by $38. So here, this is more accurate explanation to you of what this shadow price is. This is to tell you if we loosen the budget, right? Here, the budget that you have to face is limited amount of money. If I give you more superfluous availability of money, right, of budget, how much your optimal sales could increase. Okay, so here we should add optimal. The optimal sales will increase by 38, which is the value of lambda star. How did we find lambda star? We just take the optimal x and y into the first equation. You can take that into the second one, then you just have to divide 4, right, to find lambda alone.